This is the second video where I talk about graphing inequalities. In this video, we're going to talk about graphing systems of inequalities. Now, we'll still talk about the skills you need, but more of that is covered in the first video, graphing inequalities. I want to do two problems here. The first problem, we're going to take inequalities, turn them into a graph. The second problem is our ACT example, where I'm going to take a graph and turn it into inequalities, which is the type you usually see on the ACT. But no matter which way you go, the steps are going to be the same as we saw in our last video. Deal with the lines, graph the lines, then shade. Graph the lines, then shade. So I've written three inequalities here. Y is less than or equal to x plus 1, y is greater than 2x minus 2, and y is less than 6, or excuse me, x is less than 6. So I'm going to go through the first inequality, step 1, step 2, line it, shade it, graph it, shade it, graph it, shade it, graph it, shade it. And then we'll talk about solutions. Okay. So let's just start at the beginning. X plus 1, well, that's a very simple line, right? Y-intercept of 1, sort of a nice gradual slope. Again, my drawing doesn't need to be too exact. It just needs to be the right kind of picture. It needs to be factually accurate, but not necessarily pedantic or super. I don't need graph paper. You know what I mean? It doesn't have to be super scaled. Okay. Now, less than or equal to, okay, I've got a solid line because it's equal to, and it's less than, so that's going to be beneath. Let's bring some colors into play here. Got a nice blue for this one. I'll make sort of a little legend over here. So it's going to look like this. Shaded down below, goes on forever and ever, shaded down below, shaded down below, shaded down below, shaded down below, shaded down below. Okay, let's look at the next one. Y is greater than 2x minus 2, okay? Well, 2x minus 2, that's going to start at negative 2. So let's say that's here. And 2x is going to be somewhat steeper, right? But it's greater than, but it's not greater than or equal to. So I'm going to have a dashed line. So I'm just going to draw a solid line first. Say it looks kind of like this. And then I'm just going to go through the beauty of dry erase markers and just make it a dashed line. Easier for me to draw straight lines this way. And I already know my drawing's terrible. You can tell me again in the comments if you want. Okay. And finally, let's shade this one. It's greater than, right? So it needs to be kind of up here, kind of above the line. Right? Y is greater above the line. We'll use orange for this one. So all this is going to be orange. And you can start to see where your solution set's going to have to be. We'll talk about that at the end, but let's go ahead and get our third inequality up. X is less than 6. Well, if you remember, X is going to be a vertical line. It's weird. It's kind of flip-flopped. Even though X is horizontal, when I have X equals, or X equals in a line, or X is less than or greater than, it's going to be a vertical line because that means X is 6 forever and ever for all Y's. If I have Y equals just some number with no X, that means I have a horizontal line. Looks like I'm directing traffic when I do that. Okay, so draw a nice little vertical line here. Okay. Less than, it's going to go this way. It's going to go this way. X is less than this way, towards the negative side. And let's bring out a green. Okay, this is less than, this is less than. This is less than, this is less than, this is less than, this is less than, less than, this is 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 less than. It's starting to look really, really confusing, right? It's one of the reasons I think that they don't make you do inequalities to graphs, because it would be kind of hard for you, I think, to do that. But also, I think that they would have to make a lot of graphs, and it would take up a lot of paper. I don't know. I don't know exactly, but that's kind of my thoughts. So we say that a system of linear equations has a solution set whenever the lines intersect, right? So if I had a system of linear equations, this would be the solution, right? Not solution set, but the solution. There can be 1, 0, or infinitely many solutions to a system of equations. You know, 0 if they're parallel, 1 if they cross, if they intersect, and infinitely many if they just are the same line, one on top of the other. But with inequalities, I have a solution set, just like I would with an individual inequality. Where's that solution set? Well, when the solution sets of each individual inequality intersect. So it would be here. So I've got blue, I've got orange, and I've got green. So this would be our solution set. Nothing else would be shaded. So what would it really look like on a graph? You only shade the part that's the shared solution. Only shade the part that's the shared solution. So it would look more like this. It's going to take me a minute to erase this, and it's still probably not going to look very good. Sorry. It would look like this. Just this little sliver right here. Or if I want to draw a smaller version, it would look like this. Here's my 1 line. Here's my 2 line. Here's my horizontal line, and it would just look like this. That would be what is shaded. You only shade where they all intersect. Only shade where they all intersect. Let a light go out there for a second. Check out the second part of this video. I'm going to jump right into it on the same video. We're going to do an on-screen problem with systems of inequalities, much like you'll see on test day. So let's take a look at an ACT example of graphing inequalities. This is the standard problem. They give you the graph, they ask what the set of inequalities are. But I'm going to follow the same steps. I'm going to look at each inequality, decide the line, decide the shading, which means figure out which way the inequality is facing and whether or not it's greater than, less than, greater than, equal to, less than, equal to. Let's start with a horizontal line. So I've got a horizontal line. If you recall that the equation of horizontal lines, talked about this in the last video, is y equals. So y-intercept of 1, that means it's got to be y is equal to 1. Now let's think about the shading. It's below. Below for y is less than. So y is less than or equal to, because it's a solid line, 1. Okay, now I would strongly encourage you to write down these inequalities as you get them, because it's very easy to make a mistake. Look at these little sign flips, right? The little sign flip is easy to miss. All right, now I've got that one done. Let's look at this one. First thing I would check is, do I have anything that doesn't have a y-intercept of 2? I do, but I've already marked it off. Then I would look at my slopes. All my slopes are the same, so I'm not going to bother calculating my slope. Try to do that. Have that conversation with your answer choices to keep yourself from doing extra work. Okay, so this has got to be y something x plus 2. Well, it looks like I'm shading the uphill side, right? Over here I was down but not below, but now I'm above the line. So that means it's y is greater than or equal to x plus 2. Okay, so anything that's not greater than, that's less than. These two are both greater than. Okay, so what's the difference between D and E? Y, that's the same, that's the same. That's the same, that's the same. It's this operator, and that's a dirty little trick they play. Is it or is it and? Well, if it were or, everything would be shaded. That's a solution to either inequality. Oh, we could do this or that. Both are fine, right? All of this would be shaded. All of this down here would be shaded. The only thing left unshaded would be this little sliver here. But because it's and, well, because only this is shaded, where the two overlap, this downhill shading here and this uphill shading here, that means it's got to be and. That's our answer. D is out. E is correct. These aren't bad problems.